Hey guys, welcome back to Infinite Math Help Squared. Here's part 2 in our 4-part series for the Pythagorean Theorem. We are in this video finding the missing side length if it is the hypotenuse, which is, remember, the longest side. It's not one of the two shorter legs. So in the last video, in part 1, we talked about Pythagorean triples, and the triangle that we looked at was 3, 4, 5, and it was a right triangle. So for this one, let's take a look at this one and see what this will end up being. Will this end up being right, like they're telling us here in this box? Will it end up being something different? So we have x squared equals 6 squared plus 8 squared. So we have 36 plus 64, x squared equals 100. And now remember, hopefully you remember when you're solving your equations and your squares, in order to undo the square root, you would square it. And if you want to undo the square that we have here, you have to take the square root of both sides. Now, normally you would have a plus or minus square root. However, side lengths are not going to be negative, so we're going to ignore the negative part, and we will just say here that x equals 10. So we have our missing side length. It is 10. And if we have it plugged in, that means 100 equals 100. So they are not lying here. This is a right triangle, and it is one of our Pythagorean triples. Now, before we do another example, I would like in this video to also go over why this is even happening. So, for example, we're talking about squares in the Pythagorean theorem. So let's actually look at squares, because we've only been looking at triangles even though we're working with squares, right? Okay. So just imagine that attached to these side lengths here, right? Just attached to them, that we have squares. And we already solved this one, right? We know that this length was 6. We know that this length was 8, and that this one was 10. That means that each of these squares has side lengths of 10, because they're squares and all their side lengths are the same. Now let's take a look at how this works. So we have 8 times 8 is 64. Here's the area of that square. We have 10 times 10 is 100. So there's that square. And then the last one, the last leg, was 6 times 6 is 36. And this is why this Pythagorean theorem is working. We have two squares that when we add them specifically in a right triangle, not the obtuse or acute that we saw in part 1, but specifically in this one, they're going to end up being equal. If you add up the squares of the legs, it's going to equal the square of the hypotenuse. Let's look at one more example. Let's find the missing side length for this right triangle, okay? So we know they're not tricking us. I'm showing you that there's a right angle in here. This is a right triangle. And I don't want you to think that they're always going to be whole numbers. Sometimes they will not be whole numbers, and you're going to have to pay attention to the directions. Do they want you to put it in simplest radical form, or do they want you to estimate to the nearest, let's say, 10th or 100th? Okay, so let's start this out. we have our hypotenuse squared equal to our legs squared, not cubed. And now let's see. We have 9 plus 81, which would be 90. And we saw in the last example, we're just taking the square root. So we have the square root of 90. Now, they said simplest radical form, which means we actually have to break this down. Square root of 90 will break down into the square root of 9 times the square root of 10. The square root of 9 is 3. Let's just get rid of that. And so we have x, the missing side length x is equal to 3 square root 10 because the square root of 9 is 3. And that's it. This is simplest radical form, and it is the missing side length. Okay, part 3 will be coming up soon, so till next time.